Hi everyone, and welcome again to our YouTube channel. As we promised, this is the next part of our video that we uploaded to our YouTube channel about the physics, equilibrium, and the moment. So as we said, now we are going to solve the hardest questions that are comes on the MCQ and theory question. So watch this video till the end. That I promise you that if you pay close attention, that you will be able to solve all the questions related to the topic equilibrium and the moments. So let's start. As you can see, there are three forces acted on the trapdoor: the weight, the tension, and the force edge. So the which list gives the three forces in increasing order. So we need to find the increasing order of the magnitude. So let's start. First of all, we have to know that the principle of moments. So the clockwise moments are equal to the anti-clockwise moments. So let's find which are the anti-clockwise moments and which are the clockwise moments. So as you can see, there is a tension. So the tension is the anti-clockwise, and the weight and the force H are the clockwise moments. So from that we can conclude that the whole tension is being equal to the sum of the weight and the edge force. From that we can conclude that the highest magnitude, the increasing order magnitude, so the T will be the last one. So as you can see, there's the only answer we have. This is the C choice. So the T is the greatest force. So now let's continue. Now it's time for our next question. A uniform beam of mass 1.4 kilograms is pivoted at P as shown. The beam has a length of 160 meters and the P is the 120 meters from one end. Loads are 3 and 6 kilograms are suspended 0.35 and 0.15 from the pivot as shown. In the graph, in the diagram, you can see that everything is clearly defined. So what torque must be applied to the beam in order to maintain it in equilibrium? So they are asking for the apply the force in order to maintain the equilibrium. So from that we can conclude that the graph is not in equilibrium. So after we use our formula of principle of moments, we can find out that how much force we need to apply so we can make the object in equilibrium. So let's start. So we know that the moment formula is equal to, let's say m. So the moment formula is m equals to the force times the distance perpendicular to this force. So now we need to multiply the 0.35 meters times the 3 kilograms times the 9.81 because we need to find the force, so that we use the formula of the weight plus that. As you can see, there is also the mass of the beam, so that we will use this also. To find that, we need to divide the total length of the beam to the two. So as you can see, the total length of the beam is 0.60 meters. So the half of this will be the 0.3 meters times the sorry. There we need to find the distance from the pivot. So we can conclude that this distance is 0.30 meters. From that, if we subtract the 0.20, then it will be the 0.1 meters for the pivot, from distance from the pivot. So the 0.1 meters times the 1.4 kilograms times the 9.81. Now you can see this is the one side of our formula. So let's calculate it. So at the end we will calculate the both sides, then equate them so that we will find how much force we need to apply. Times 9.81, so the plus 0.1 times the 1.4 times the 9.81. So the answer is being 11.6739. So the one side of the beam is giving this much moment. So found out that now it's time for us to find the other side so that we can equate them and find how much force we need to apply for this. Okay, now let's find this one. So as you can see, there's the only weight we have, so we will just multiply the 6 times the 9.81 and times the 0.15 meters, 15 meters, so that we can find out the other side of our moment. So 6 times 9.81 times the 0.15. So the other side is being 8.829. So there, as you can see in our graph, how much force we need to apply to make it in equilibrium. You can see if we subtract the 8 from 11, so that it will be the largest one, which is the 2.8 meters. So we found out that using the principle of the moments. So to never forget the formula, just click the subscribe to our YouTube channel, and also in this video below that we put our link to our Telegram channel, so that from Telegram channel you can find out the summary table. From summary table there are everything on our video that we done last time about the equilibrium moments and other. So let's continue to our next question. So this kind of question, that as you can see there are string, so the string, this string probably tells us that this question is about the tension. This question is the one of the hardest questions that I've ever seen. So let's understand this question and solve, then you will be able to solve all the tension questions. So let's see, there are two blocks, the masses are given, connected by a light inextensible string that passes over a frictionless pulley. So they are saying that the frictionless, so that we don't need to pay attention to this. So initially they are held in stationary, then the block of mass 0.20 rests on a rough horizontal surface, the other one is suspended in air. So now we need to pay attention closely to there, so that they have the acceleration off, so that after they are released. So that as we know, now we need to equate the two sides so that we can find the tension, and also they're asking for the frictionless force between the block mass and the rough surface, so that they're asking for this frictionless surface which is acting on this side. Found out that, so that we can find the answer, sorry. So let's continue. So first of all, we need to find how much force this mass is applying. So the 0.5 times the 9.81, which will give us, let's see, 0.5 times 8. So it gives us the 4.9. Okay. Also, this force is acting in this direction. So the tension that is giving the opposite direction should be the same as this one. so that we found out that the tension acting on the opposite direction of the weight is the 4.9 Newton. So, as we know, if this tension is acting on this direction and the weight is on this direction, so this is the same as for this one. Now, also we need to find the frictionless force after they are released. So this is the total force we have. Now we need to subtract it from the after they are released. So the after mass is released, how much force we left. So that this will be our answer. So as we know, the force is equals to the mass times the acceleration. So from that we can calculate the both sides with the acceleration, so then we can subtract them. Okay, now let's see. So the 0.20 times the 2, also plus to that 0.5 times the 2, so this will be the 1.4. So we found out that the 1.4 we need to subtract from our total force, so that we will get the final answer, which is the frictionless force acting. So if we subtract this, this will be the probably 3.5 newtons. Gives us the answer A. So let me just summarize what I did. So that I found that the weight and the tension, so that this tension will be the acting on this direction also, so our total force will be 4.9. Then I need to find that after the release, so that I found out how much force that are subtracted after the release. I found out using the simple formula force equals to mass times the acceleration. So let's see. That's it. So let's continue. So this is the one of the good questions. So let me introduce this question. This is called the double pivot questions. So as you can see, there will be the two pivots in the diagram. So you need to find how much force acting to the both of them. So when it comes to moment questions, these questions simply the hardest questions. Just watch and how I solve this question, then you will be able to solve by yourself also. Or you can pause and try by yourself, and after I solved, you can check the answer. So let's see. The plank rests on a fixed support at its ends, x and y. So the child with a weight of the 600 newtons. So we need to find the force F vertically upwards, which is x on the x. So we know force will be applied by the weight of the child on this direction. So some kind of reaction, the opposite force should be act from the x point. So we need to find that. If we know that, let's write the moment formula. Moment formula is equals to force times distance. From just using the single formula, we can solve this hard question. So let's see. So there are in the answer, as you can see, F when x and F when y. So when the child stands on the x and the y. So we need to find two forces at x when the child stands on x and y. So first of all, let's find the x1. So if the child stands on x1, its weight will be 60 newton, and the times the distance from the y, because when calculating the double pivot questions, you have to focus on the both two pivots, and if they're asking for the x1, you have to use the y1. If they're asking for the y1, you have to use the x1. So this is the best case scenario and the best kind of trick for you to use on the exams. So we will multiply it by the 4. And also there is something left, sorry, there's also the weight of the beam uniform plank, so we have to use this one. So we will add this, and also from the center of the gravity, center of mass, there will be also the 300 newton. So let's add this one, 2 times 300. So as you can see, this will be 2400 and this will be 600. So the final answer will be 3000 newton meters. So this is our final answer for the anti-clockwise moment. So as we know the principle of moments, the opposite moment should be the equal clockwise to the anti-clockwise. So then we'll use this total our moment to find the how much force acting to the x. So we will just use this formula. 3000 is equal to force times the 4, because the distance from the pivot is 4 meters. So then the F will be 7 and 50 newton. So from that we can conclude that the answers only left we have is C and the D. So let's continue and find out the Y1. So same as we have the total, we had our total moment. So from that we will use this also. So when a child sits on the Y, if the child is there, so there will be the 0 distance from the pivot. So if we multiply any force to that, it will be 0. So we can conclude that. So only option we have is the weight of the beam, weight of the plank. So we will use that. So when the child there, we will use that 4 times the 4 acting will not be equal to the 3000 acting on the force, so the distance from the x. So then there will be the child will know kind of work, or we don't need this child, so this will be equal to then the 2 times the mass of the our beam. So this will be the 6000. So our total one will be the 6000. This will be equals to this. So if we just divide it by 4, it will be the 150 newtons. So from that we can conclude that the D is the correct answer. So you can just pause, or you can watch again how I solved, so this will be really helpful. So when just before and you're preparing for the exams, so click subscribe and like to support us, and on the comments write what topics that are difficult for you, or you are suffering, so that we can make for these topics the video also, so that it will be helpful for you. We will be really happy if you just tell it on the comments. So thank you, and it's time for our next question. So this is also one of the confusing questions I have seen on the exam. So as you can see, there are two diagrams that are given, and they are asking for in both cases the string is attached to the same points in the picture. So as you can see, this picture and this picture are the same, so that we can say that the weight of the both of them that are acting on this direction will be the same. So we will use this one. So from the answers you can see that they are asking which one is correct. So R1 is equal to R2, or which one is greater? Kind of like question. So let's see. As you can see that in this case R1 will be equals to the weight, which is weight of the picture. In this case, which is for the R2, this is the also same as the weight acting on the opposite direction. Because there are any other forces that are acting the opposite direction. So we can say that if they both are equal to the weight, then this is the same picture, so that we can conclude that the R1 is equals to R2. Then we can just cut and eliminate the C and D choices. So the let's say the T1 is greater or the T2 is greater. You can see we will use in this case the components of the T1. So that as you can see, there will be the one component of the T1 which is on the vertical and which is on the horizontal direction. As you can see, we need this, which is this one. So that after we found out that will be the equals to the R1. So if we just do that, then let me just make it more clear. If we just make it so that this angle, which is theta, this theta will help us. So in this case we will use the cosine theta times the T1, so then it times the 2 will give us the R1. So this is our first equation, sorry. Now it's time for the second one. As you can see, this will be the same for the second one. Theta 2, there are two components also, but in this case cosine theta 2 times the 2 will be equal to the R2. So R are equals to each other, so that in this case the angles are working the role, so they're playing the huge role. So from this you can see that if the which angle is smaller, then it will be the cosine. After the answer from the cosine, it will be the higher. So from that we can just conclude that if which angle is smaller, the force will be higher. So as you can see in the T2, the angle is smaller, so that we can conclude that the T2 is greater than the T1. So the answer will be A. Answer will be A. Answer will be A. Sorry. Just in case. There should be equal to the R1. So in this case, so if the angle is playing role, so the T1 is higher than the T2, because from the higher elimination from the cosine from the angle, it's being using is the same as the component of the T2. So there are high elimination in the angle, but the T1 is still being equal to the R1, and also T2 is being equal to the R2 by the cosine. So the angle greater, the force will be greater. So the answer will be B. So as you can see, this is our last question, and let's solve. Then you will be, as I said, you will be the master. You will be the expert in this field. Okay, let's solve. So the weight will be, and then tension. Yep. Before just reading the question, you can just look at the graph and just draw something for yourself that will be helpful for you, because in the exams there will be less time. So just do the tricks, and you have same the single question, so that maybe you can use this time for the other question, so that will be better. So let's solve this question. As you can see that the weight is acting on this direction, so if the force acting on this direction will be the same for this, and there will be the two components of this force. So we use this, from that we can conclude that, sorry for the question left, but this is our last question. So from that we can use the tension formula. If the angle is this, and from this equals to the weight, this we will use the sine theta. From that we can just eliminate the cosine ones, because we will use the sine theta. So the sine theta times the weight will give us this tension, and also we need this 2 times. So 2 times the tension, so that we can just say that the answer is because there is also tension in this direction, so that in the rope tension acts for the whole rope, so that we need to multiply it by the 2. So that, as you can see, there is only answer for this, which one is B. So if you liked, this is the end of our questions, and thank you for your attention. Just never forget to subscribe, click the like and the comment, so that see you on our next video.